Everyone, we're going to do derivatives with our primary trig ratios, and we're just going to focus on sine and cosine today, and we're going to add things like tangent, cotangent, and secant and cosecant in a future lesson. But we're going to start off reviewing derivatives by going old school and talking about first principles. So way back in chapter 1, we made you do first principles, and we kind of said, well, we're not going to have to do that very often, but it's kind of nice to see it when you're learning a new application. So if we want to use first principles, I kind of highlighted here a little foreshadowing. I'm going to be looking for cos x minus x. I'm going to actually looking for sine x over x equals 1 as well in our identities from our limits. So we're connecting past lessons, and we're kind of shrekking our math. We're just going to add some layers to a couple of things here. So when I plug into my first principles, sine of x plus h turns into a sine sum formula. So you go to your formula sheet and you find the sine of a sum, and you plug in for x plus h. So it's not a plus b, it's x plus h. And then you start looking for how do you use your limit identities. And we do some grouping, we kind of do some rearranging. We just put the sine x with the other sine x, and we're going to put the sine h kind of off by itself. And then when you have fractions and you have a common denominator under all three terms, you can put an h under all three terms, or put an h under two of the terms and under the third term. So we're kind of doing some reverse fraction adding here. And the reason we split it this way is when you factor the sine x out of this term, you get cos h minus 1 over h. That's a limit identity. And here you have sine h over h, sine h over h. That is a limit identity. So we get to plug in, as h goes to 0, we get to plug in the value. And our first identity is 0, sine h over h. That identity is 1. So using first principles then to find our derivative, right? We're gonna simplify this expression and just get cos of x. So how do you find the slope of sine x? Well, if you want to know what the slope at any point in the function is, you find the cosine value of it. So the derivative of sine is cosine, and that's a limit proof. What we want to be able to do is we want to be able to show you that you can actually do this as well by looking at the graphs. And maybe I'll make my screen just a little bit bigger here for us in this one. Let's just zoom it a little bit bigger, and maybe that might help us see kind of what's going on here. We're talking about critical numbers is what we're doing. And critical numbers is where the slope equals 0. So I got a bunch of slope equals 0 at the top of my curve and a bunch of slope equals 0 at the bottom of my curve. Every place I have a slope of 0, right below there, I put slope of 0. And where we have a slope of 0 in the bottom, I put right above it, I put a slope of 0 point as well. And then we go back to kind of like our graphing chapter. If your function's decreasing, you've got negative slopes. So when I go from a 0 slope to 0 slope, this area right in here, this is basically saying that all my slopes are negative because my function is decreasing. Right above here at this 0, so from this point in the function going up to the function, all my slopes are positive, and that's why I put all my slopes being positive in here. And I keep that pattern going, negative slopes, positive slopes, negative slopes, positive slopes. What I get when I look at the slope function of the sine, I get this red, green graph, and that red, green graph is actually the cosine graph. So we can see graphically that the slope of the sine function is given as the cosine function. So that's a graphic interpretation of the identity, other than using limits. And we can do the same thing then, is how do you find the slope on a cosine function? So what are your critical numbers? All right, so I found 5 critical numbers. I put 5 0 slopes there. Where's my function in this? I guess my function is decreasing. So I've got negative slopes, right? So I got some negative slopes happening. My function's increasing from there to there. So my positive slopes, right? My function's got positive slopes, so my function's increasing. And then again, my function's decreasing. So my function's decreasing. I got a region of negative slopes. So when I go from my negative slopes to positive slopes to negative slopes to positive slopes, I don't get a sine function. I get a reflection of the sine function. So the slope of a cosine curve is always going to be negative sine x. All right. So we're going to stop our video here. We're going to do a second video that shows how we use this information. Cosine, derivative of cosine is negative sine, and the derivative of sine is cosine. We're going to use those properties now to actually take some derivatives.